Number 4, you're asked to match the 3 quadratics to their graphs. There's a couple ways you could do this. First, if you want to kind of analyze each graph. Looking at graph A, a couple things I notice. It's going down, so that means my x squared should be negative. And it looks like the parent function, because parent function, if graph down, you would go from the vertex. You would go to the right one, down one, and you would see an ordered pair there. And you do, and to the left and down one. So it looks like the parent function. Part B looks like we have a transformation. The vertex is no longer at the origin. It looks like it's one to the right and one up. So from that vertex, if you try to plot the parent function from this to the right one, up one, again, it lies directly on the parabola. So it looks like this is the parent function just shifted. For part C, we're back at the origin. And if you look at the graph, if you try to plot the parent function, this graph goes wider than the actual parent function. So narrowing those down should really help you match. So number 1, I see a negative in front of the x squared. The only one that is negative, the one going down instead of up, is graph A. For number 2, 1/3 x squared. So it looks like we're at the origin. It didn't shift any. And that 1/3 just represents, we did an exploration where we were looking at how that number in front of the x squared changes the graph from being more narrow and wider. If it was a fraction, less than 1, it would make it wider. So we kind of observed that in part C. And then for number 3, we definitely see a shift. Our vertex, if we would actually pull it out from number 3, it's in vertex form. The x-coordinate is always opposite sign, 1, and the y-coordinate is a back number, 1, 1. Well, we saw that graph B was just a shift of the parent function, and that new vertex was 1, 1.